Assalamu alaikum warahmatullah. I hope you are all well and having a good day. Today we will solve Edexcel IAL Physics Unit-1 May 2024 question paper. This is a really important question papers for the October 2024 and Jan 25 candidates because it's the latest question paper that we have. So let's start solving this question paper from question number 1. In the question number 1, they have said an engine is used to remove water from a mine. The engine transfers energy to the water at a rate of this to the water and wastes energy at a rate of this. So basically the thing is the engine transfers energy to water and to wastes. So this is our power. This 2 is our power input, right? This 2 overall 180 and 60 is our power input, and our power output is only 180 because this 60 goes in vain as this is the waste energy. The energy which is converted to the water is our power input. We know the formula of efficiency is power output by power input. As this 60 kilowatt plus this 180 kilowatt, these are the overall power that has been transferred from the engine. So we can say this is 240 overall, 180 plus 60, and the power output is only 180 kilowatt, which is the energy that is transferred to the water. As the main objection of doing this is to transfer or remove water from a mine. So our answer is question number A. So moving to the question number B. In the question number 2, they have said the graph shows a velocity of an object varies with time. So this is a VT graph. They have asked to find out how the following describes the motion of the object. They have asked us to find the motion of the object. As it is a VT graph, we know the gradient of VT graph gives us acceleration. The gradient of VT graph gives us acceleration. So let's do the question. One thing while solving the multiple choice questions is the elimination method. You have to eliminate some points. Like there is displacement given, so this graph is not regarding displacement. So we can eliminate B and D. So we're left with A and C. A cannot be the answer because the gradient is not constant. The gradient is like this. The gradient is decreasing. So C is our answer. Moving forward to the question number 3. In the question number 3, they have said an object is moving through a fluid. So an object is moving through a fluid. Which row of the table that conditions Stokes' law? We know whenever something is moving through a fluid, it has to be spherical, it has to be small, and the fluid around him needs to be laminar and it cannot be turbulent. So let's see which row changes. A can be removed because it says any. It cannot be any, it has to be small. So B also can be removed. B is not the answer either. A and B is not our answer. It has small, it can be our answer and it can be our answer. Spherical is similar, but it is not spherical. It has to be spherical. Our answer will be C, not the other answers. So moving to the question number 4, they have said which of the following expressions gives a vector quantity? We know density into volume. This is not the vector quantity. Here is given mass into velocity. We know mass into velocity means momentum, and momentum is a vector quantity. Force into distance. Distance is not a vector quantity. Displacement should have been there. And power into time. They are neither vector quantities as well. And this is not vector quantity. So our answer will be C. And here our answer will be B. So we are done with question number 4 as well. Moving forward to the question number 5, they have said a student stretches a spring of original length P. This is the original length to Q. So it has been stretched by applying an increasing force. The force has been applied in this direction. The graph shows how the length of the spring changes as the student increases the force from 0 to magnitude R. So as the force has been increased, the length has also increased from this position to this position. So which of the following gives the stiffness of the spring? We all know stiffness means K, and we all know the formula F is equals to K into X. And if we have to find the stiffness, we can subject this K, which is F divided by X, and the force is R. Here they have written the force as R. If the force is R and the change in X means change in length, which is from P to Q, so we can say Q minus P. So the answer will be this. Moving forward to the next question, they have said which of the following expression gives the work done stretching of the spring before its original P length to Q. So they have talked about the work done. We all know the area under the fx graph. The area under the fx graph, we all know the area under the fx graph gives us energy stored in the spring. So this energy stored is our work done. So area can be found out by half into base into height. So our base here is R into the height is Q minus P. So we can say our answer will be R into Q minus P divided by 2. This is our answer, because half into R into Q minus P means R into Q minus P by 2. So our answer is B, omitting all the other answers. Moving forward to the question number 7, they have said which of the following describes the center of gravity of an object. We can say center of gravity means the point at which the whole weight of an object acts. They have said where the mass is not the answer. Center of gravity means the weight. So this C and D can be the answer. They have said the point where the weight of an object is located with the object. They didn't mention, they have mentioned located. It is not located, it can be considered to act. So our answer will be D. The answer of question number 7 will be D. So moving forward to the next question, we can see that it has written a student is determining the acceleration of free fall. A student is determining the acceleration of free fall. The student uses a stopwatch to measure the time taken for a ball bearing to measure distance. So he has been calculating the time taken of the measured distance. So the distance is constant and he is measuring the time taken, and he is measuring the free fall actually. They have said the student calculates a value of G that is greater than 9.81. Okay, the value of G is greater than 9.81. It is not equal to 9.81. So the G is not equal to A. So why is this happening? Which of the following could be an explanation for the student's result? We all know when something is falling from free fall, we can say S is equals to half AT square, which is half GT squared. So we can say if this is our formula, S is equals to half GT square, the G will only be affected if something has happened to the displacement or to the time, because G is inversely proportional to the time squared. So if the time squared decreases, only then the G will increase. As they have said that the value of G is greater, that means the time squared has decreased. That's why the G has increased. And when the time squared will decrease, when the times calculated will decrease, the time has decreased means the time calculated will decrease. The time calculated will decrease when the student has started the stopwatch, just 1 or 2 seconds later it has started the ball bearing to drop. So we have to see that question right now. The 8 number will be the ball is moving downward. Yes, the ball is moving downward. It's quite right when the student starts the stopwatch. So it means that the ball already started moving downward when the student has started stopwatch. By using this, the time will be less. It will have a lesser time. So this is our answer. So let's see why the ball B is not answered. The ball is moving upward. The ball is never moving upward. If a ball moving upward, then it will not be in free fall. So we can omit this answer. In C number, they have said the student started the stopwatch before the ball bearing is dropped. So the time will be greater. It has started the stopwatch before. So time will be greater. But we are looking for time lesser because the G was greater. In a D step, they said the student stops the stopwatch after the ball bearing lands. So it was the time was perfect. But we are not looking for the perfect time. We are looking for the time where the time is less. So the perfect answer will be A. Question number 9, they have said a student attached one end of a wire to a support. The student added masses to the other end of the wire as shown. The student measured the corresponding extension for each added mass. The wire broke when the extension was small. The wire broke. The student replaced the wire with a second wire of the same material. The material was same. It had a larger extension before breaking. So the second material has a larger extension before breaking, whereas the first wire had extension, very small extension before breaking. So which of the following produced this result? So we all know the formula of Young modulus is stress by strain, and stress by strain is stress is force per area, and the strain is change in length divided by original length, which can be written as F into L divided by A into del L. E is equals to, and if we make the del L the extension of our subject, F into L divided by A into E. So this extension is directly proportional to the original length. So if as the extension has increased, we can say the original length was greater. So the second wire had a longer original length. That's why the extension was greater. Moving into the question number 10, we can see they have written a ship has a mass of 1.2 kg, which is our mass, and this is our acceleration. The force provided by the ship's engine is this. This is the force provided by the ship's engine. And which of the following expression gives the magnitude of the drag force? So they have asked us to find out the drag force. So if we look after this question, we can say, which according to Newton's second law, we know F net is equals to mass into acceleration, right? And we can say F net is equals to the force of the engine minus the drag force. They have asked us to find the drag force. So F of the engine minus the drag force. And here we have been asked to find out the drag force. So the FD will be F engine minus F net. So here our F engine is this, and this is our F net, mass into acceleration. So we can say our F engine is this minus 0.03 into 1.2. So our answer will be A. Not here they have given plus, they have given divide, they have given multiplication. All of these are bullshits and these are not answer. The actual answer will be question number 10. So we are done with all the multiple choice questions.